Hello and good morning to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss paging in operating system. As we all know, size of main memory in any given architecture is very limited. This limited memory is to be utilized in order to facilitate multiple processes perform its desired behavior. Moreover, the objective of an operating system is to always enhance the degree of multiprogramming. That is, to fit in as many number of processes in the main memory. So in order to perform this, operating system adapts a mechanism known as paging. So let us try and understand how paging works. So paging divides the processes in forms of uniform size, that is called as pages. So paging divides processes in forms of pages. So pages are blocks of representation of same size. Likewise, the main memory is divided in forms of frames. So here process is divided in forms of pages and main memory is divided in forms of frames. So what it does, it retrieves processes from the secondary storage device into the main memory in forms of pages. So here, instead of loading the entire process onto the main memory, pages belonging to a process is loaded onto the main memory as and when required. So once the execution is over, associated with a particular page, the page is placed back into the secondary memory. So here it retrieves processes from the secondary storage into the main memory in forms of pages instead of loading the entire program. One page of a process is mapped onto one frame of the memory. So one page is mapped onto one frame of the memory, which implies page size should be same as that of the frame size, or page size needs to be as same as that of the frame size. Pages of processes are brought into the main memory only when they are required, otherwise they reside in the secondary storage. So this is what we have already learned. So whenever a page belonging to a process is to be executed, the page is brought from the secondary storage onto the main memory, it is executed and it's placed back to the secondary storage. If a page is not to be executed or is not required at a particular point in time, it will reside in the secondary memory. The pages can be stored at different locations of the memory, but the priority is always to find a continuous frames or holes. So here, just see, pages belonging to a process can be stored at different locations in the memory or different frames in the memory, but the priority is always to find continuous frames. This implies that paging does not mandate allocation of continuous bytes of memory to the frames belonging to a program. So this is one of the biggest advantage of paging. So paging is a technique that eliminates the requirement of continuous allocation, because in the traditional way or way of allocating memory to the processors, so whenever processors are bought onto the main memory, the processors were bought at entirety and stored in continuous memory location. So in case of paging, we divide the programs into identifiable pages, and only when the page is to be executed, the page is brought from the secondary memory onto the main memory. And moreover, it does not demand continuous memory allocation, which implies pages belonging to a process can be stored at different locations in the memory. So this is one of the biggest advantage of using paging. Now let us try to understand paging with the help of an example. So let us consider there are four competing processes, P1, P2, P3, P4. P1, P2, P3 requires 4 pages, whereas P4 requires 8 pages. So here we are assuming that there are 3 user initiated processes. In addition to the operating system, the processes are there are 4 user initiated processes in addition to operating system, that are P1, P2, P3, P4, requesting for 4, 4, 4 and 8 pages respectively. So here what we have done, we have allocated P1 page frames to the pages of process P1, P2 and P3. So since P1, P2, P3 requires 4 frames each, so what we have done, we have allocated 4 frames to the 3 processes P1, P2 and P3. Now let us consider that P1 and P3 completes its execution. So P1 and P3 leaves the system. So when P1 and P3 leaves the system, the memory is to be deallocated. So whatever memory that was allocated to P1 and P3 is to be deallocated. So once it is deallocated, it can be used by any other process that is there, that is to be executed by the processor. So here what we need to do now is we need to now load the process P4 from the secondary storage device onto the main memory. But here, since paging does not demand continuous memory allocation, so what we can do is we can allocate discrete chunks of memory to process P4. So here the memory that was initially allocated to P1 and P3 is now being allocated to process P4, which is non-contiguous in nature. So this is the way how paging works, or paging performs its operation. Now let us try and understand some of the advantages and disadvantages of paging. The first advantage is that it is capable of efficiently handling larger programs, because in case of paging, a program that's to be executed by the processor is divided into pages, and only the relevant page that is to be executed by the processor is brought onto the main memory, whereas the rest will reside in the secondary storage. So paging facilitates efficient handling of larger programs. It increases degree of multi-programming, because definitely assisted by paging we can have more number of pages belonging to multiple processes simultaneously coexisting in the main memory. So paging does increase degree of multi-programming. Now it reduces external fragmentation to save memory. Paging is very simple to understand and easy to implement. So this is one of the biggest advantage of paging. Now due to equal size of frames, swapping becomes very easy. So a movement of frames to and from the main memory becomes very easy, because in case of paging the pages are of same size, and it allows for faster access of data. So these are some of the notable advantages of paging. Now let us discuss some of the disadvantages of paging. The first disadvantage is that paging has its own memory overhead. The overhead is because in order to implement paging, or in order to perform paging, we need to implement a page table. Page table is a table that keeps track of the status of all the pages that are there in the memory. So paging involves memory overhead, because a page table is to be maintained that keeps track of the status of the various pages, and generally page table is very big. Now, since there is a page table that is involved in paging, additional time is required for memory reference. So additional memory reference will be needed to access the page table, which definitely will increase the total amount of access time. So these are some of the notable advantages and disadvantages of paging technique. Now let us talk about page replacement algorithms. In order to improve on the degree of multi-programming, a subset of pages belonging to a process are loaded onto the memory. So this is what we have learned. So in order to improve on the degree of multi-programming, a subset of pages belonging to a process are loaded onto the main memory. A page residing in the secondary storage is brought to the main memory as and when it's required by the processor by replacing an existing page in the main memory. So as and when a page associated with the process is to be executed by the processor, the relevant page is brought onto the main memory by replacing an existing page that is there in the main memory. Now the process of replacement, as we have learned, is called as swapping. So swapping is the process for moving the pages belonging to a process from or to the main memory. Now page replacement is done when requested page is not found in the main memory. So this is to be understood. A page replacement is to be executed when the requested page is not found in the main memory. And this task is performed by the page replacement algorithm. So the page replacement algorithm is responsible for performing the task of bringing in or sending out a page from the main memory. In addition to that, the page replacement algorithm also decides on which memory page is to be replaced and when it is to be replaced. And as I've said, the process of bringing in or moving out page from the main memory is called as swapping. Now let us discuss some of the fundamentals that are associated with page replacement. Now the first fundamental is called as page fault. Page fault is said to have occurred when an executing program in the CPU attempts to access a page that is in its address space, but the requested page is currently not in the main memory. So whenever a process wants to execute a page belonging to it which is in its address space but which is not in the main memory, then page fault occurs. So page fault occurs when an executing program in the CPU attempts to access a page that is in its address space but the requested page is not currently in the main memory. Now in situation when a page fault occurs, the operating system has to replace an existing page in the main memory in order to fit the newly requested page. So therefore, the page replacement algorithm helps the operating system in deciding which page is to be replaced and when it is to be replaced. So the primary objective of all the page replacement algorithm is to minimize the number of page faults, because more the number of page faults, more the number of swapping operations to be performed, more will be the amount of time that will be required for executing the process. So the primary objective of any page replacement algorithm should be to minimize the number of page faults. Now there are two key aspects that are to be focused on related to virtual memory. Now first one is called as frame allocation. That means how many number of frames are to be allocated to a process whenever a process wants its execution. And the second one is how page replacement is to be done whenever a page requested by the process is not there in the main memory. So these are the two important aspects of interest in virtual memory, that is frame allocation and page replacement. Now it's very important to have an optimal frame allocation and page replacement algorithm. So it's very important for us to have a very strong frame allocation and page replacement algorithm in place in the operating system to facilitate paging. Now frame allocation, as I've said, is all about how many frames are to be allocated to a process, while page replacement is all about determining the page number that is to be replaced in order to fit a requested page. So frame allocation is all about how many frames are to be allocated to a process whenever a process is to be executed, and page replacement is all about determining which page in the main memory is to be replaced and when it's to be replaced in order to make space for a requested page. Now, what if the algorithm is not optimal? So let us consider that the algorithm that we have pursued is not optimal. So what does it happen? So when the number of frames allocated to a process becomes insufficient, then it leads to a problem that is called as thrashing. Again, I'm repeating it. When the number of frames allocated to a process becomes insufficient, it leads to a problem that's called as thrashing. Now let us try and understand what is thrashing. So thrashing basically refers to a situation wherein the process spends more time in paging rather than on execution. So this means in situation when a process invests more amount of time in performing swapping in and swapping out, so this process is referred to as thrashing. So thrashing refers to situation wherein the process spends more amount of time in paging rather than on execution, that is performing frequent swapping in and swapping out. Consequently, more swapping and swapping out results in frequent page fault. On the contrary, if operating system allocates more frames to the process, then internal fragmentation is destined to take place. So if more number of frames are allocated to a process, then definitely internal fragmentation is destined to happen. So here, less number of frames would result in thrashing and more number of frames would result in internal fragmentation. So that is the reason why optimal number of frames are to be allocated to the process during its course of execution. Now, if the page replacement algorithm is not optimal, so now we are talking about page replacement. Till now we were talking about frame allocation. So if the page replacement algorithm is not optimal, then there will also be the problem of thrashing, because if the page replacement algorithm is not optimal, then frequent swapping in and swapping out is required. So if more amount of time is required or invested in swapping in or swapping out rather than on execution, so it leads to a problem of thrashing. So if the page replacement algorithm is non-optimal, then there will also be a problem of thrashing. So in case of frequent use of frame, more number of swap in and swap in swap in and swap out are required, causing performance deficiency. So since it's definite that if you have more number of swapping in and swapping out taking place whenever page replacement is being done, so the performance of the system is destined to degrade. So in case of frequent use of frames, more number of swap in and swap out are required, causing the performance to degrade or leading to performance deficiency. So therefore, the task of an optimal page replacement algorithm is to choose the page which can limit the thrashing, or the objective of optimal page replacement algorithm is to devise a mechanism which enables it to select appropriate page that is to be replaced in order to make space for a newly requested page in a manner that it limits thrashing or it reduces the number of page faults. So these are some of the important aspects that needs to be focused on whenever paging is performed. So in today's class, what we have learned about is we have learned about what is paging, we have learned about the various characteristics of paging, then we have learned about how paging works with the help of an example, and then we have learned about some of the advantages and disadvantages of paging, and then we moved on to page replacement algorithms. What should be the considerations, where we have discussed what should be the considerations of page replacement algorithms. Then we talked about some of the fundamentals associated with page replacement, and then we talked about the need for optimal page replacement algorithm. So in the next class we will discuss some of the important page replacement algorithms that are used in different operating systems. So thank you very much. Have a good day.